Hello everyone, I'm Gavin Lu from VMware. Today I'll talk a little bit about edge device, which was mentioned quite a few times in last talks. Let me share my screen. You may find that edge device is a pretty widely used and fuzzy word. We introduced edge computing, Kubernetes for edge, and some other relative concepts in last talks, correlate for computing, but we didn't introduce the details of edge devices. It cannot be easily described just in words because different instruction from different people and companies standing in different positions. Recently, I created a kind of table to show the characteristics and many different aspects of edge device. Sharing in the talk, you may get some sense about how edge device is different from edge server, from cloud, from fork, and how that different from endpoints in certain degree. You may find I categorize all these different types in teacher size: extra small, small, medium, large, extra large. I didn't put endpoint here in the table because here a kind of implicit definition for edge is that it's used for multiple purpose, but not for a single target. If a small device, a small chip or module is designed and used deployment for just a single purpose, like collect data from single sensor or single data source, I call it generally endpoint, but not edge, because endpoint is kind of purely OT relative assets. Where here edge, we mean that the intersection point between the IT world, ICT world, and the OT world. So edge means multi-purpose assets in the context. On the far right column, you may find the extra large column, which is pretty clear. It's about something pretty big, rich context, rich resources like the college, like for computing, edge servers, tackle edge, things like that. It can run multiple applications in different packages, either as container or run on Kubernetes or virtualized or even hyper-converged infrastructure included there, and that could be run as a cloud fashion operated from the cloud. So this column is not strictly defined as the edge device. It should be like we call it a cloudlet or for computing in a certain degree. On the left, L size. That's kind of also similar to the rackable server in the cloud in data center, or like the cloudlet, but the number and the detailed storage size might be kind of limited compared to the cloud. It could run the containers, also run full-fledged Kubernetes and virtualization. But it's barely capable to run the hyper-converged infrastructure, which means the shared storage or service storage, because there are not many disks, either HDD or SSD installed there. Considered by the size, we find that the size is also kind of compact, generally maybe 1U mostly. And considering that it's not quite straightforward to operate as a cloud from the from data center, because maybe for one site there are just one or two box, one or two rack server-like boxes there. So still kind of limited, but compared to the left side, it's kind of rich enough to run many form factor applications there. So it's sometimes called edge server in many cases, which is okay, because it's capable to run many applications there already. But here, consider about the size form factor, like a server, rackable server. I exclude that from the edge device too. And on the left, there are three columns. I call these three columns edge devices because they are small. Their form factor is also quite different from the rackable servers, and their size is generally, the resources, the richness of resources also kind of quite limited compared to the rackable servers. So first, the middle size now maybe capable to run Kubernetes and certain Kubernetes distro, maybe a compact distro, but it's kind of awkward or in certain degrees not a full cannot run full-fledged virtualization, and for hyperconvergence it's not impossible, because maybe there are just one or two disks at most in the box, so you cannot do that actually. And of course, you cannot do that. You cannot run operate the box, maybe just one or two on the edge as a cloud fashion from the data center. So here, virtualization is the kind of maybe not. If the users have some smaller, even smaller box, according to t-shirt size small, it's capable to run container, and maybe not capable to run full-fledged Kubernetes, considering that there are multiple processes or container instances, the processes on the control plane node, on the worker node. If you consider all things like kubeadmin, kubelet, API server, proxy, things like that, it's not quite suitable for that. Maybe some corner cases you can run that, but maybe most of the resources will be consumed just by Kubernetes services, which is not typically expected by the users. So they will prefer to run container and some very specialized Kubernetes distro just designed for edge. And virtualization generally no, they generally prefer bare metal. And of course, no hyperconverged because there is just one storage component, and of course, no cloud operation from data center, which is pretty small and also quite cheap. On the most left side is extra small. Kubernetes, yeah, that's possible if you choose some compact ones like Containerd. But for Kubernetes, it's kind of challenging because at least size, there may be just 1 gigabytes. Kubernetes is kind of challenging, even for compact distro designed for edge. Of course, it's not recommended to run virtualization, and there is no possible to run on this hyperconverged infrastructure, stack on that small. Look at this small form factor. That's a Raspberry Pi 0W. It just includes 500 megabytes memory, and of course, the cloud operations. There is just one maybe TF card or maybe eMMC's chip on the module. It's hard to say it's a cloud node, right? It's not reasonable to say it's a cloud. So you can just operate that node in remote fashion. So if you look at the table again, pay attention to the color of all these cells. You will find all these yellow, all these red ones marked for yes. It's a triangle, right? Right triangle. And for every column in a smaller size of T-shirt, you may find that the capabilities goes down lower and lower. And that will explain the difference of a different size of edge devices. And for device here, I mean mostly about the nodes which could not be operated by the cloud, or the form factor, the size of box is quite different from the rackable server. So there are quite a lot of challenges here to manage tens of edge devices in certain locations for enterprise users. How shall we handle all this? And how to manage the data lifecycle remotely on the edge devices, and how to manage the native applications on these edge devices remotely. It's also another challenge for the enterprise users. How to handle that? That's often a question we want to tackle and address in certain degree in the later talks. So that's all the information we have for today about edge devices. Thank you for your attention, and see you next talk.